I'm Abaniya, Assistant Professor, Department of Food Technology. In this session, we will explore water in food, what it is, the type of water found in food, and why it's matter in food chemistry. When we look at the food, we often think of color, taste, and texture. But behind all of that is one crucial component, that is water. So it's everywhere from the crispiness of fresh vegetables to the softness of bread. So and it plays a central role in everything from a texture and shelf life to spoilage and flavor. So in this session, we will first get a quick overview of what food chemistry. So, and then we will dive into the concept of moisture in food, and we will learn about the types of water present in different food system and how this moisture affect food stability, quality, and processing. Introduction to food chemistry. Food chemistry is a scientific study of chemical composition, structure, and reaction of food components. So, in this field, seeks to understand how these components interact with each other and how they affect the overall quality, safety, and nutritional value of food product. In food chemistry, the bridges and the gap between chemistry and food science. So, applying the chemical principles to solve the problem related to food quality, processing, and nutrition. So next we move on to the chemical compositions. Involves the analysis of molecular makeup of food. So it covers the macronutrients, micronutrients, and other components. In micronutrients, it include vitamin, minerals, and macronutrients, it include carbohydrate, protein, fat. The other components are water, pigment, uh, flavor component. So next we move on to the chemical reaction. So in this we will study how food component interact during processing and storage, such as oxidation, hydrolyzation, and Maillard reaction. So, next, functional property. In this, we explain how the chemical change affect food quality. For example, change in texture, change in texture, gelatinization of starch, development of flavor compound, and stability during a processing or shelf life. So next, importance of food chemistry. First, we will see quality control, product development, food safety, and nutritional science. In this, first we will discuss about quality control. First, in quality is ensure the food product meets safety and quality standard. So it involves the chemical analysis of ingredients and the finished product to detect the contamination of flavor on spoilage indicators. So in product development, it's help to formulate a new food product and it improve texture, taste, stability and shelf life. So use of chemical reaction and ingredient to interaction. So next in food safety, so it's identify and manage the chemical hazards to prevent contamination and spoilage. So in contamination, like examples are heavy metal, pesticides. So and also it minimize the spoilage by controlling pH, water activity and preservation. Next, nutritional science. So in this topic, we understand how food chemistry affect nutritional ability and health benefits. So in health benefits through fortification and bioavailability. So and also it support functional food and dietary guidelines. So next we move on to the moisture in food. Moisture in food is the amount of water present in food item. So it includes water that is free and can be easily removed, as well as water that is bound to the food component. So the moisture affect the texture, taste, shelf life and safety of food, and as usually it's measured the percentage of food total weight. So next we move on to the role of moisture in food. So in this, the texture and mouthfeel, the softness and juiciness is high moisture content often lead to the softer texture and to enhancing the juiciness of foods like fruit and meat. Next, we move on to the crispiness and crunch. So it's conventionally low moisture level to contribute the crispiness and crunchiness. So it's essential product like crackers and chips. So next, flavor. In this we will flavor release and flavor stability. In flavor release, moisture facilitates the release of flavor component. For example, juiciness of ripened fruit enhance its flavor. In stability, the proper moisture level can prevent flavor so loss during a storage, and some excess moisture can lead to the flavor degradation or the development of flavor. Next topic is nutritional value. So in food with higher moisture content generally have a low concentration of nutrients. Per unit, for example, fresh fruit have a less concentrated vitamin compared to dry fruit. In next, preservation and self life, the microbial growth, a high moisture level can support the growth of bacteria, mold and yeast, so it's lead to spoilage. So low moisture level inhibit the microbial growth. Enzymatic microorganism, the moisture can activate enzymes that cause the spoilage, such as those responsible for browning in fruit and vegetable. For in chemical reaction, the Maillard reactions and lipid oxidation. First, in the Maillard reaction, record a moisture to occur, so it's responsible for browning in baked goods and roasted foods. For example, bread. For lipid oxidation, the water can influence the rate of lipid oxidation, so it's affect the rancidity and of flavor. So in water, there are three types of water. One is the free water, another one is bound water, absorbed water. First was we will see free water. For definition, the water that is not chemically bound and is available for a microbial growth and chemical reaction. So the characteristics are, so it's easily evaporate and remove. High free water content can lead to the rapid spoilage and microbial contamination. Example, water in fresh meat and vegetable. Next topic is adsorbed water. The water that adheres to surface of particles or food structure. So the characteristics of the adsorbed water is it's often involved in the stability of powdered foods. So it can affect texture and self-life. For example, water in powdered milk or flour. So next, the bounded water. For the water is a chemical or physically bound to the food component such as protein or carbohydrate. The characteristics for bound water is less available for microbial activity and also it helps in maintaining the texture and structure of foods. Example for bound water is the water bounded texture of bread or within the gelatinous jellies.